Hello. Today we are going to do an experiment on projectile motion. We are going to study how to get the muzzle velocity of a projectile, and also we will calculate the horizontal range and the maximum vertical height of a projectile at different launching angles. But first, let me introduce you to our equipment. I have here a projectile launcher where I can change the angle by loosening the screw at the back here and then rotating, thereby changing the launching angle. The angle is determined by this angle indicator, which is positioned at the back or at the end of the projectile launcher. In front of the projectile launcher, we have two photo gates. The first photo gate will detect the projectile as it passes through, and it's indicated by this light. And then as the projectile passes through the second photo gate, it will be detected as indicated by this light here. Now the projectile we are going to use is a steel ball, which I have in my hand, okay? And how we install it is actually by placing the ball inside the muzzle and then taking a plunger, which is this one here on my hand, and then pushing the ball in, thereby compressing a spring. Now, the strength by which we can launch the projectile has three levels: 1, 2, and 3. As a precautionary measure, we are only going to compress the spring with one click, or basically the lowest setting. Also, for safety, you must be wearing safety glasses, as I am doing now. To launch the projectile, we have a trigger, which is this, okay? Now, I'm going to launch the projectile which I placed inside the launcher. I'm going to block it with my lab manual so that it will not fly off the table. Make sure that the ball is not going to fall off the table so that you will not lose it. We are also going to use what we call time of flight accessory. Basically, it is a sensor where our projectile is going to land or hit. That is going to allow us to measure the time it takes for the projectile to leave the launcher and reach the ground. In order to pinpoint or determine where a projectile will land, we are going to use a piece of paper, which we are going to tape over our time of flight accessory. And then we are going to place a carbon paper. The impact is going to leave a mark on the paper, and from there we can measure the distance horizontal that is traveled by the projectile. Now let us begin. We are going to use a software called Capstone, and you will have a file which is available for you on the desktop. Open the file that says initial velocity of projectile. Make sure that your interface is on and that it is connected to the computer. Next, you want to set your projectile launcher at a specific launching angle. In this case, we are going to do 15, 30, 45, 60, and 75 degrees. Set your launcher or launching angle at 15 degrees. Once it's set, place the projectile inside the launcher. You must make sure that the angle doesn't change. Take the plunger and push the projectile in until you hear one click. In the first table, we are not going to use the time of flight accessory. We are only interested in the muzzle velocity or the initial velocity of the projectile. You can take your lab manual and you can block the projectile from flying off the table. What you will do is click Start to record, launch the projectile by pulling the trigger and taking a reading from your computer. Make sure that you click the Stop button. Once you have your recording at 15 degrees, change the angle of your projectile launcher. At 30 degrees, again, place your projectile inside the launcher. Take the push rod, click the record button in your software. Make sure that you have your paper or book blocking the projectile from a certain distance, and launch. Click the Stop button. Now you have your second reading. Repeat by changing the angles according to the table and recording the readings each time. Now it's time to make the table 2, which is the maximum height and the horizontal range of a projectile. First, adjust your launcher so that, again, with the angle indicator, you will be set at 15 degrees. Make sure that the angle is set accurately. Next, place the projectile inside the launcher and then use the plunger so that you will compress the spring by one click. Next, make sure that the software horizontal range is open. Close the software for the initial velocity. Make sure that you have your time of flight accessory with the paper taped on top and a carbon paper placed over it. We will not use it in the first instance because what we will do is first to make an estimate of where the projectile will land. Once the projectile and the projectile launcher is ready, launch it and watch the ball or the projectile. The projectile landed somewhere in this area. So what you will do is you will take your time of flight accessory and place it in the general area where the projectile landed. Next, place the projectile inside the launcher again. Prep the launcher with just one click using the push rod or the plunger. And then this is very important. Click record on the software. And finally, launch the projectile by pulling the trigger. I missed it. If you miss the time of flight accessory, just make sure that you stop recording and repeat the process. Press the record button and launch. Now, the first thing you must do is to get back or catch the ball, remove the carbon paper, and on the time of flight accessory, you will see that there is a dot that is created by the impact of the ball on the surface of the carbon paper. That would be your angle or measurement at 15 degrees. You can write the number 15 over this dot. Next, click Stop on your software because it will not stop automatically by itself. Keep the ball on the magnetic holder so that you don't lose it. Now it's time to measure the horizontal range. You have with you a meter stick or a tape measure. How do you measure the distance from the projectile's muzzle or the mouth of the projectile launcher up to the landing area? It's simple. On the projectile launcher, you will see here a small circle. That is where the launch position is, or the mouth of the projectile. That would be your 0 from your meter stick or your tape measure. Making sure that the meter stick or the tape measure is horizontal, place the beginning or the 0 where the launch position is, and then read how many centimeters away is the landing. That is where the horizontal range of the projectile traveled. In this case, it traveled 66 centimeters. Record it in your data sheet. Let's do the next angle. Adjust your projectile launcher to set it to 30 degrees. Again, install the projectile. Use the plunger to compress the spring. Now this time, what's going to happen? Because we changed the angle, your projectile will not land in exactly the same place. So we have to estimate it again. Take your time of flight accessory, the landing pad, move it off from the landing area of the projectile, and then launch the projectile. Okay, I determined that the projectile landed in this area. So I will take my time of flight accessory and place it in the same area. Click the stop button. Install the projectile. Always when installing the projectile, make sure that the recording is stopped. Start the record button and then launch. There you go. Now we have our second recording. Take the initial speed as well as the time of flight, record in the data sheet, remove the carbon paper, and then measure the distance from the launch position up to the dot that was left on the time of flight accessory. This dot, you label it as your 30 degrees. Do not move your time of flight accessory until you are able to measure the horizontal range. Again, using your meter stick, start by placing the 0 at the launch position. Now, if your meter stick is too short, what you can do is to simply add. Take a pencil or a pen and mark where the 1 meter distance is. That's 100 centimeters. And then from there, just continue measuring until you reach your 30 degrees. In this case, I will have to add 6 or 5 centimeters. So the horizontal range at 30 degrees is 105 centimeters. Record that in your data sheet. To do the rest of the angles, just repeat the same process. Always make sure that before you place the projectile inside the launcher, make sure that the software is not recording. Click the stop button. That is our projectile motion experiment.